have three types of column and a compression member. We are going to study these three type of compression members. First one is long column or a member. So you know there are three types of column, which are long column, short and intermediate. So between these three, you can use Euler's formula for solving the long compression members to find the buckling strength. If you are having short compression member or a short column, what you can do is finding the failure stress by finding the yield stress of the structure, that is stress equal to load by area. Simply you can use that formula to find the compression strength. But if you are using long column, you have to use pi square EI by L square. This is Euler's formula, since you need to find the buckling strength. And the behavior of intermediate compression member might be they can yield and also they can buckle. So these two possibilities are there. Their behavior is inelastic. So first, before analyzing a member, you should check it either it is a long compression member or short member, or it's intermediate. So within these three, your solution will be there, and it adheres well for your solution. By using this stress strain diagram, we can understand what is long column and what is short column. You can see that this is load in y-axis and change in length in the x-axis. You can understand that Py is the force, at what force the member is breaking. Okay, what is the formula? You know Fy is called stress. Stress is load by area. Y, they have indicated Y in the sense yield stress. Y stands for yield, F stands for stress. So if you want to find yield stress, you have to find yield load, that is Py divided by A. So you are cross multiplying here. If you need yield load, what will be the yield load of the column? If you want to find that, if the member is purely a short column and which will be failing through a compression mode only, for that you can use this formula. And if you are using a slender member, this is for a short column, which is very stocky compression member, stocky in the sense very short. If you are having a slender column, note that half of the strength is nearly reducing. The same column, if you are using for 1 meter height and you are checking for the load, it takes 100 kilonewton. And if you are making 1 meter column, the same compressive strength, the same material you use, but you extend their height for 5 meters. What happens? The length is increased. So increasing the length, what happens? The column will become to next mode. It might be intermediate column or a long column. If it is increased for the same material, the stress is, the load carrying capacity is going to get decreased. So your formula changes like this, Fy into L by E. So this is the formula which is used to find yield strength at the member. Here yield strength changes. So this is what the behavior. When you want to study the content of behavior of compression member, you have to study these two. Okay. When your material is purely under compression mode, you know that you have a definite stress carrying capacity. This is brittle. The brittle material does take the load, which is the yield load. When you are increasing the yield load, so it will not get changed. So this is the mode of failure. So idealized material behavior for rigid and plastic. Rigid is brittle. So it is also called brittle. What is the brittle material? Concrete is a brittle material. So for a concrete, you will be having a stress strain graph like this. So this is y-axis is stress and this is strain. So it will be a straight line. If you want to find what is the reason for decreasing the strength, is due to, first one is imperfection. This is what I said in the last classes. Your column will be having imperfection. That is, if 250 mm by 300 mm is given in your dimensions, there might be imperfections while constructing. So this is one reason why you are not taking the whole load, and initial lack of straightness. The column will not be straight throughout from the bottom to top. If you are checking that, you can use theodolite for finding the straightness of the column. You can check that for a multi-story structure. If you are checking, there will be deviation from the ground floor to the top floor. The column will be having slight deviations. So due to this deviation, the column or the compression member might not be able to take the load. What formula you are using? Stress equal to load by area. This formula you cannot use. Why? Because this is the second reason. First one is imperfection. Second one is the column will not be straight. If you are making a steel member, then your accuracy is much more higher. Why? Because steel member are precast. So your accuracy of straightness will be much higher. And if you are making concrete element, so your perfection might get lagged. And accidental eccentricities of loading, residual stress. So due to these reasons, your column is taking the reduced load and it is buckling. Now you take IS 800 table 10, the buckling class of cross section. Check the page number 44. When you want to design a compression member, your member is either I section, this is rolled steel I section, and this is welded I section. What is the difference between that? What is rolled steel and welded I section? Rolled steel is being casted in the manufacturing stage itself. What do you mean by welded section is, you will be making in the shop, you will be getting flat, so these are all called flats. So you will be getting flat sized member and you will be welding either in shop or in your site. So if you are using rolled steel I section, you have to use this limits. Okay. Now what are these limits is, if this is a beam section, first limit is H by B suffix F. What do you mean by that? H is height, you can see the terminologies here. H is height and BF is flange breadth, that is breadth of flange. So this is the B suffix F. Okay. If you are knowing this, you have to use this condition. This is higher than 1.2 and this is lesser than 1.2. So you have to check the height by breadth of flange. So with this ratio, you have to check the buckling class. If you are using I section, which is having a height by breadth flange ratio which is lesser than 1.2. If this is in the case, you have to go for the buckling class of B, C, D. So here the conditions are given. If your thickness of the flange, TF is what? Thickness of the flange. Here you can find the thickness of the flange. If it is lesser than 100 or greater than 100, so you have to check. So when checking these conditions, you can find the buckling classes. Why you are referring this table is, when you are designing a compression member, you have to specify the class, that is buckling class you have to specify. How you are specifying that? According to the member. If it is a welded section or I section, still you have different classes. If you are designing a hollow section, hollow might be a circular hollow or rectangular hollow or a square hollow. This is square and rectangle. So you can have this kind of structure. Then you have to use, what is the buckling class here? A. So you have 4 classes of buckling, A, B, C, D. So under what class it is coming, you have to check with this before welding certain things. Okay, welding the box section, when you are using channel L, T or these sections, you have to use the buckling class C. When you are using built up member, what do you mean by built up member? When you are using 2 conventional member, that is 2 I sections, you are purchasing separately and you are making the weld and you are making composite of a section, then it is known as built up section. You have to go for class C. Now you take down table 11, effective length of prismatic compression member. Where is it available? Page number, the next page, table 11, you can see the effective length. if one end is fixed and other end is free. In your problem, they will give the conditions. Either it is fixed or hinged, like that, they will give conditions. You have to check here. One end is fixed and other end is free. If this is in the case, if the length of the column they have given 10 meter, you have to multiply by 2L. What do you mean by 2L is 20 meter. So likewise, you have to check for all the conditions. So this is one end fixed, other end free. One end is hinged and other end is roller. They have given the each end. So either you are restraining to translation or rotation. So like that they have given. Okay. Now you are having this much of columns or this much of compression member which they are using in the practice, in the design of steel structure. This is being selected based on functional aspect of the structure. If you are connecting with the girder plates, that is for a truss. In a truss you will be having the compression members. There you can use single angle section. But if you are using for a column, I want to cast a column and I want to build that. So you will not use the L sections there. It differs. So there you will be using rectangular section. For a column you will be using rectangular or square, like this kind of section. For any truss members, the compression members will be in this mode. So how these members are being selected is functional aspect of a structure. What is the function of the structure? Either it is going to take purely axial or it is having axial load, bending load in combination. Okay. Now functional aspect of the member. What member you are using? The compression member might be in beam, you can have the compression. Not only in column, you will be having compression in a beam. So what is the functional aspect of the member? Which member you are using? According to that, you have to select this. Then easiness of connectivity to other members. When you want to connect with another member, see, you are using a hollow rectangular section and you are selecting the bolt. You are placing a hollow rectangular member as a column. Now you are selecting bolt as your connection. If you are bolting at one end, you have to have the access at other end, yes or no? If you are not having access, you cannot go with this section. If you are having L section, can you bolt at this end easily? You can drill with one end and you can easily bolt with the side. So certain shapes are not easy to connect, and if you are using welding, the hollow rectangular section is very much easy. You can provide the hollow section and you can weld it. There is no axis required. So how the axes are available? According to that, you have to select this section. And higher radius of gyration. If you need, so radius of gyration R is very important parameter in designing the compression members. If you are having higher R value, R is known as what? Radius of gyration. If any member is having higher radius of gyration, that member will provide high yield strength. In designing, you will check that. So these are the four aspects how you should select the member. In the design, they will indicate that use a compression member for a load of 1000 kilonewton. The length of the member is 5 meter. You have to select the design. So you have to select the cross section. How you will select? According to these aspects. Okay. Now take down a problem. Determine the design axial load capacity of ISHB. What do you mean by ISHB is Indian Standard Heavy Beam. H stands for heavy and B stands for beam. Beam is known as I section. Here they have given is an I section is being given at 577 Newton per meter. If the length of the column is 3 meter and its both end are pinned, so their condition is given. You have to find the load carrying capacity of this member. They have given a case of both the ends pinned. Criteria it is coming. Check the table 11. So you identify that what condition it is there. What is your condition here? Both the ends are pinned in the sense hinged. Both are same. What is your case? See, this is the condition. This restrained for translation only. You can see both the ends are hinged. L is 1 times L. Okay. Now the second table I have shown you. What is the buckling class? Now you have to find H by BF. Now you divide H and BF. Okay. How to find this parameter in the sense you go for annexure H. Turn the annexure H. You will be having ISHB. In annexure H, you can see ISHB 300. So this is what they have given, and they have given two ISHB 300. Can you observe this? They have given two same sections, but what is the difference is the first ISHB is 63 kilogram per meter. The second ISHB is 58 kilogram per meter. So what is the case in your given data? Either you have to use 63 or 58. 577 is in Newton. How to convert into kg? Divided by 9.81. 58.8. This is the class you have to mention. Okay. Now if you are having this section, what are the other things they have given? Thickness of flange, that is TF. Thickness of web, TW. Radius of gyration, section modulus, all the components they have given. The width of the flange. So now you have to refer this. What are the given data is? First write these data. Fy is yield strength, which is 250 Newton per mm square. Fu is 410 Newton per mm square. So these are the given data. E equal to 2 into 10 power 5 Newton per mm square for both the ends hinged. First you have to find H by BF. What is H? 300. Yes or no? Height of the member. Divided by what is BF? Breadth of flange, which is width of flange is 250. Now you divide 300 by 250. What is your answer? 1.2 you are getting. H by BF is 1.2. And then what is thickness of flange? TF is what? Thickness of flange is 10.6. So it is lesser than 40 mm. Now you check this table. Your class comes under. Here you can see this is less than 1.2 and this is more than 1.2. Since your value is coming exactly 1.2, you go for this value. Now your thickness of flange is lesser than 40 mm, isn't it? What is your thickness there? 10.6. So for this is lesser than 40 mm, hence you can use this case. Your YY will be, your buckling about axis will be YY, and you have to take buckling class B. Now this is your data. Now after selecting this, it falls under buckling class B. Now in your code book you have this list of formula. You take down 7.1.2, class 7.1.2. Check the page number 34, look into that. Can you find this formula? What is PD is design load. What is your question asked here? What is the design load for your column? Now your design load is, they have given the formula. Design load for any compression member is PD. So PD equal to AC FCD. What do you mean by AC is? Effective sectional area as defined in 7.3.2. Then what is FCD is design compressive stress as given in 7.1.2.1. Now if you check the class here, are you having the formula for FCD? FCD is Fy. Do you know Fy here? Fy is given. Do you know gamma M, material strength? Where you can find that? Table phi 1.2. How to find phi? So this is phi here. Phi is 0.5 1 plus alpha, lambda minus 0.2 plus lambda square. Now you have to find alpha and lambda. How to find lambda? They have given the formula as Fy by FCC. Now, how to find FCC? They have given pi square E divided by KL divided by R square. So, if you find FCC, then you can find lambda and you can substitute and you can move further. So, what is important here? FCC, that is Euler's buckling stress, is most important here. Okay, now how to find this? Pi square, you know it is a constant. E is Young's modulus. What it is given in your problem? 2 into 10 power 5, which is effective slenderness ratio. Now, what is your effective slenderness ratio? What is your effective length? L equal to 1 L. So, your L is same. So, what is your length? 3 meter. Now, your KL will be 3 meter divided by what is R? R they have given there. What is R? R is radius of gyration. Can you find radius of gyration in this table? What is least of radius of gyration here? See, in the annexure H, you can find radius of gyration. You have 12.95 as RZ and 5.41 as RY. What is the least of that? 5.41. Now, it is given in terms of centimeter, isn't it? Check that the unit is in centimeter. Pi square into 2 into 10 power 5, 3000 divided by 54.1. Now, check that, are you getting 641.92? You will be getting this value. After finding this value, you can substitute to find lambda. How to find lambda? You know that. How can you find lambda? Fy by FCC. Whatever value you got, you divide that and root, you will be getting lambda here. And for finding alpha, how to find alpha is they have given a separate table, table 7. So, what class you have to select? From here you got the class. What class you have to select? Class B. For class B, what is the alpha? 0.34. So, instead of alpha, you have to substitute here as 0.34. In the alpha here, you will substitute 0.34. Now, lambda you have found out that 0.624. Now, the components are known here. See, all your values are here. FCC you can find it. You will be getting divide it and root. You will be getting alpha as 0.34. Lambda you got, you can find phi here. And if you know phi, you can substitute here. And lambda already known, you can find FCD. And after finding FCD, you can substitute here. And area, that is the cross sectional area. It is given in the annexure H for I section. You multiply that and you will be getting design load. How to find FCD? Fy by gamma MO. Fy is 250 they are given. If you are substituting these values, we will be getting FCD as 187.36 Newton per mm square. So, if you got that, FCD will be known. And in that formula, what is the other component is AE, that is effective area. 7484 it is substituted here. Where you will be finding this? Can you find the area here? Area of cross section 74.85. They have given in annexure H. In terms of what unit? Centimeter square. You are substituting everything in terms of millimeter square. So, you have to multiply by 100. Then you will be getting this value as 7485. If you multiply with 187, you will be getting this value. And in terms of kilonewton, 1402 kilonewton. This will be your answer. Now, for finding working load, you have to divide it by factor of safety, which is 1.5, and you can use 934.8 kilonewton in that column. If See, a column member is given, that is ISHB, for a size of 300. What is the load carrying capacity of this member? 934. So up to 934 kilonewton you can apply the load. If you are going beyond that, then the section is not sufficient. It will buckle and fail. Now what they have asked? They have given a section ISHB for the two grades, that is 577 Newton per meter. For this grade, what is the load carrying capacity they have asked? Finally, you have found that the load carrying capacity is 934, which is your answer. And if you are giving more load than that, what will happen? The column will buckle, that is, it will bend. Your column will bend. Okay, now you have another technique which is much easier than this to find this load. They have given the component of chi here. So this is the component of chi. Table 8b, they have given the column buckling class B, 8b, and in that you have different buckling class A, B, C, D. You have 4 classes. You have to check class B. Okay. Now, what is your KL by R value? 3000 divided by 55.45. Are you getting that? Yes. So, if you are checking that, the values are given for different numbers, for from 10, 20, 30. So, your 54 comes in between 50 and 60, isn't it? Okay. Now, what is your Fy? Fy is yield strength. What is your Fy for your problem? 250. Then you check for 250. For 50 KL by R, your Fy is 0.855, and for 60 is 0.798. So this is your answer. Now, can you interpret and find for 55.45? Now you can directly multiply. You can use this formula, or you can use, so what is your value you are getting? 0.8823 into Fy divided by gamma MO. You can use this formula or you can use this formula. Check that, are you getting the same answer as FCD? Now you have the third technique. First one is given, second one is finding psi value. Third technique is design compressive stress by using table 9b. You check with table 9b. Previously you have checked 8b. Now you check 9b. You have the table for finding FCD for buckling class B. They have given the yield stress value directly. For 50 they have given directly as 194. 60 they have given for 181. Now you can interpret for 55.45. You will be getting these values. For 50 you are having 194. For 60 you are having 181. If you want to find 55.45 is, the difference here is 5.45, and you can find the x value which is 7.08, and if you add with 181 you will be getting 188.08. You can use this technique also. For solving a single problem, the code given 3 options. Either you can use lambda and phi, you can find all the data and you can do. Second technique is finding the psi value. You can multiply with Fy and find the solution. Third solution is they have given table 9b. Directly you will be having compressive strength, that is FCD. What you need here? You need FCD only. Directly you can take it from this table and you can multiply with the area and find the answer. Which technique is easy for you? 1, 2 or 3? Third is most direct. So in future problems you use any one technique, you will be getting the answer. In exams you can solve by any one technique and you can get full marks. But the best way is use the third technique, that is 9b, compressive stress directly. First find KL by R value and you can solve this easily.